Hello guys, I'm RAKSHITH from Team Let's Learn. We are going to conduct a group mock interview for the SCI candidates. So first of all, we'll move on to the introduction. So first I would like to call about Smith. Can you give me an introduction of yourself? Are you there? Can anybody give me your introduction? Be confident guys. Viraj, why don't you give your introduction?
Yes, sir.
Okay,
Good evening, everyone. Sorry,
no problem. Go on, go on.
just turning on my camera. Good evening, everyone. My name is Viraj Kanade. I graduated with a degree in mechanical engineering from University of Mumbai. During my time in engineering college, I was an active member of MESA, where we organized events and seminars for mechanical engineering students. I was also an active member of ISHRE and ASHRE, which was an organization focused on HVAC&R. ASHRE also sponsored our research on heat transfer through pin fins, which was my final year project. And I was also a passive member in SEA India. I grew up in Sindhudurga, a place known for its mountains and beaches. After completing my 10th, I relocated to Mumbai to pursue my further education. In
Okay,
my free time, I play esports and networking with new people to participate and play together. That's it, sir. Thank you.
okay. You can also talk about your parents' profession because interviewers are mostly interested in that also. So do you mind?
Yes, sir. My father is a businessman, also a farmer. He works in Kuda, Sindhudurga, and my mother is a part-time teacher. She takes classes. Now she's retired, and she's a working housewife.
Oh, okay, Viraj. Rahul, would you like to give your introduction now?
So, good evening, sir, and good evening, everyone. My name is Rahul M, and I pursued my schooling education, that is the SLC, so what we call in Karnataka state. I have completed in from Kannada state with 87.53 percentage, and next with the PUC, that is the pre-university education with 81.3 percentage, where the place where I pursued was Kodagu, which is full of like mountains and hill stations. Then I relocated to pursue my degree, that is bachelor's degree in marine engineering itself, to Mangalore, coastal area. And in engineering life, like I would like to give like I was a member of almost all the organizing teams which we conducted throughout the 3 years batch. And since 1 year was the corona hit part, and almost all the 3 years I was part of my organizing team, where I could gain more ideas about the oncoming, like upgoing AI technologies to the mechanical part which were upgraded. Then I came to know about the part where some points were lagged, and got through the major project, which was like a gas detection system used to detect the hazardous gases about butane chain in confined spaces, which can be used in our marine industry itself. This was a major part of my major project idea in the 4 years. Then I like talking to my hobbies is like networking through people's where because I have to travel 200 kilometers through my holidays. So I can go up to various places, various peoples, and knowing about their day-to-day activities, cultures, etc. Then I got to know about the like uh, different hill stations where some parts of the nature attracts to us, right? Those places were more interesting fact to me. In my free times, I used to go visit there and get to know about the people's their knowledge, their language, their accents, etc. And coming to my family background, my father is a businessman who runs his own business, and mother is housewife. I am having an younger brother. He's studying second PUC.
Okay,
Thank you.
okay, Rahul. So basically, how I want you to tell you guys is first of all, tell your name. Then you can tell where you studied, how much percentage you have gotten. Then you can tell your interest in a short manner, not very long, because also they have to hear you. You shouldn't lose the interview. You should always make it interesting to them. And next is tell your strengths also, and then any competitions you participated, any extracurricular activities you did in that order. It is much better, much more weightage to your professional life. Okay, Rahul, it
Okay,
was
okay,
good. Okay, you did marine
okay.
engineering, right?
Yes, sir.
Yeah, nice, nice. Okay, Vansh, would you like to go next?
Sorry, sir, I can't able to answer right now because I am outside. So sorry, sir.
Okay, no problem. Varun, would you like to give an introduction of yourself?
Good evening, sir. I am from Karnataka. I have completed my class 10 in Muraji Desai Residential School, Karnataka State, and overall percentage is 80.80. And I have completed my class 12 in MES Chaitanya PU College in Karnataka State, and overall percentage is 73.16 percentage. And I have completed my bachelor degree in marine engineering from Visvesvaraya Technological University in Karnataka, and overall percentage is 73 percentage, and overall CGPA is 8. And when it come to my family, my father name is Hanmatappa, and mother name is Basama, and I have three elder sisters and one elder brother. And coming to my father and mother occupation, my father is a farmer and mother also farmer. Then uh, my hobbies in free time, playing with cricket and watching movies. That's it. Then that's it, sir.
Okay, okay. So, I
Thank
think,
you.
okay, thanks. So, let's see, anybody else? Abhishek, do you want to give your introduction of yourself?
Yes, yes. Hi, Rakshit. I am Vijay Kumar Singh, born and brought up in Jamshedpur, Jharkhand,
I think your
a
mic
small
is
state
not
in India.
audible. Can you fix that?
Hello, I'm audible now.
Okay, you can go on. Please tell.
It's not loud. It's okay now.
A bit inaudible, but you can go. You can try it. Go. I can hear you.
Okay.
Go.
I'll speak more. So, hi, Rakshit. I am Vijay Kumar Singh, born and brought up in small state of Jharkhand, Jamshedpur. So, and I did my mechanical engineering from National Institute of Science and Technology, Barampur, Odisha, and scored a percentage of 76.5, having a CGPA of 8.08. I did my schooling, I did my matriculation from Sri Krishna Public School, Jamshedpur, have a percentage of 70. I did my intermediate from SR Public Senior Secondary School, Kota, Rajasthan, and scored a percentage of 81.80. I was a working professional. I worked 1.5 years as an extrusion training engineer, where I worked on multiple projects to actually mold a pipe. So, as an engineer, I was an operator in my department. Apart from that, after that, I started preparing for merchant navy as well as gate. So, my hobbies are to play extra outdoor games like cricket, football. I am more into outdoor person. Apart from that, my achievements are I was a sprinter in my inter school. After that, I hold a medal in my college as well. So that's all on my side.
Okay. Okay, Abhishek, that was a very good introduction. So one thing I would like to say is everybody who has already a working profession, there is very high chances that you will get some questions based on that from the interviewer. Basically, they'll be asking what you did all this year, what experience you have gained, and there might be a slight possibility that they might ask question on basis of the field itself. Okay, so I want everyone to be prepared for that if you are in a working profession. And people who are still studying, there might be a very high chance they might ask about the project you have done in your engineering background. So next, Munif, can you give me your introduction? Munif, are you there?
Yes,
Okay, give me your
I'm
introduction.
audible.
Yes, yes, you're on.
Good evening, everyone. My name is Munef Nirburkar. I am from Ratnagiri, Maharashtra. I am completing my Bachelor of Engineering in Finland Academy of Management and Technology, and also I am completing my HSC in Ratnagiri, Shrima Ramesh Jikir Junior College of Science, and I'm complete with the 63%, and I'm complete the SSC from the Natinagar Vidya Mandir Nate with the 80.60%. About my family background, my father name is Munir Abdul Ghaffur Borkar and he was a fisherman, and my mother is a housewife.
Okay. Any interest you would like to mention? Any strength, interest, achievements?
Uh,
Okay, Munif, it's okay, no problem. So if it is better if you prepare for that. It is better to mention any achievements or anything that you did, any interest at least, any strengths at least. So, Shaurya, are you there? Can you give me an introduction?
Okay.
Shaurya, are you there? Okay, Mugesh, can you tell me an introduction of yourself?
Sir, myself, Mukesh from Tamil Nadu. I completed my UG in Karpam College of Engineering, Coimbatore, Tamil Nadu. About my parents, my father is a chief officer, my mother is housewife. About my schooling, I studied in St. Thomas Metric Higher Secondary School, Thuthukudi, Tamil Nadu. About my CGPA, I secured 8.5 CGPA in in whole year. Uh, Final percentage is about 8.75 percentage. About my final project, free vibration characteristics of honeycomb sandwich beam. First of all, we have done in two method. First is ANSI software. By using ANSI software, we find out the result by using ANSI software and experimentally done the project. Two methods. And also, main objective of this project is to find a elastic constant, bulk modulus, Young's modulus, and Poisson ratio. In my project, the result is not same. Some defect in ANSI software.
Okay. Uh, what is that you mentioned at the last?
ANSI software.
Yeah, there was some defect in it.
Yes, a value is not coming. Something in we have not find out. Something error is coming. We have to find out. So research is still going on
Okay.
in college.
Have you not passed out or have you passed out?
Passed out, but
Okay.
we have to submit the paper conference
Okay,
that is going
conference.
on.
Okay, okay. So the research is still going on. Nice.
Research is still going on.
Okay, you can mention it like that. Okay, the research is still going on and the
Uh,
values are yet to be
yeah.
obtained. Don't tell errors
Okay, sir.
or problems. Okay.
Okay, sir. Okay, sir.
So back to you, Abhishek. I want to tell why do you want to join Merchant Navy? You already have a very good profession, I guess. And why do you want to join Merchant Navy? Change from that previous profession of yours.
So the reason being joining a merchant navy because it has first of all I got inspiration from my brother. Actually, he's a seafarer in Royal Caribbean, and my uncle actually served Shipping Corporation of India for 9 years. So I got inspiration from them. Actually, sailing has always been an exciting job. First of all, it gives vast opportunities as well as it gives you experience of the nature which you won't see usually. So from that and yes, and financially I was okay, but the challenge was the job which I was doing was not exciting. So for that week, I was preparing for the gate, looking for the PSA companies, and also preparing for merchant navy, looking for a shipping company. So that's the reason I wanted to switch my job. Looking for exciting job.
Okay, that is a good answer. No problem. Varun, can you tell me why do you want to join Merchant Navy?
Sir, I have 7 points, sir. Where in joining the merchant navy.
Okay.
First one is money, sir. Money matters because I am my family background is very poor, so I need money. First one. Second point, less competition, sir. In merchant navy, less competition. So then third point, visit and travel around in world, exotic places are visit. So fourth point, and stay with parents after sign up, and and mentally and physically maintain the onboard ship, sir.
o- Okay, Varun. First thing is don't upright say money. Always say that I will gain some financial stability. Okay.
Yes, sir.
And
Yes, sir.
second thing is, I don't think it's very respecting to their fields if you say it is less competitive. Okay, Merchant
Okay,
Navy
sir.
is competitive. It has been competitive a few times. So don't tell like that that it's not competitive. Okay. Rest,
Okay, sir.
whatever you said is okay. Yes, that you will get to travel a lot. And
Yes, sir.
another thing is those other 6 months where you're signed off, you can be with your parents. But other 6 months also you'll not be with your parents. That might be a question the interviewer put up for you. Like, what about the other 6 months? You'll not be there with them, no? So are you physically prepared for that? So that kind of questions is also uh, possible. Okay. So Mukesh, why do you
Okay, sir.
want to join Merchant Navy?
Because I love to work with missionaries, and since my uncle is also a chief engineer, he will motivate me to become a officer in sea in ship. And every my uncle is inspired me, and whenever he put status on WhatsApp, I will inspired his work. I will I will also becoming my uncle. So I want to join merchant navy. And also when I was studying fourth standard, I built a career and aim to become a marine engineer. I fixed my aim. It's a fourth standard itself to become a merchant navy, to join merchant navy. So I will join. So I will join marine engineer.
Okay, so you did your marine engineering, right?
No, sir, mechanical.
The one question they'll ask, like, if you have always been passionate, why didn't you join marine engineering? Why mechanical engineering?
Because due to PCM, sir.
Okay, okay. Okay, Mukesh, that is okay. Again, you can frame it in a better way. You have a good story. You can tell that my uncle is already a chief engineer, and he always tells me stories how exciting his career is. Also, he tells me about the good and the bad of the career, and all the good stories that he told has made me passionate towards this field. And I also love working on machineries and core mechanical fields. So that's why I chose merchant navy as my career. You can frame it in a nice way. Okay.
Okay, sir.
Okay. Once, do you want to tell why do you want to join merchant navy?
Sorry, sir, can't answer right now because I am outside.
Ah, okay, okay.
I already
I
said.
forgot. Sorry, sorry.
Sorry,
Um, okay. Munesh, do you want to tell why do you want to join merchant navy? Okay. Viraj, what about you?
Yes, sir. Yes. Uh, I want to join Merchant Navy because it's challenging and a rewarding career. The opportunities to travel around the world and a dynamic environment is incredibly appealing to me. Additionally, the Merchant Navy offers a structured career path where you get promoted by an exam. So that's a pretty good choice for me, which aligns with my long-term goals. Um, I'm particularly drawn to the sense of comradeship. Teamwork and teamwork required in this field, as well as the responsibilities and discipline that the field requires. I believe that my skills and determination makes me well suited for this career.
Okay, Viraj, that is a very good answer. You told everything perfectly for that. And okay, Mohammed Ibrahim, do you want to tell why do you want to join merchant navy? Mohammed Ibrahim, are you there? Okay. Um, Rahul, what about you? Why do you want to join merchant navy?
So I would like to say like at the time of finishing my at it was at the time of my last some of the last days of 12th standard where chief officer or the institute officer came who was he was a second engineer and he told me he introduced to a whole class where this is the career where you can be very well structured, well disciplined, and you can get opportunities in a drastic manner where you'll be promoted with lots of opportunities to go not alone with only with exploring the world, but you can be well disciplined, mannered, well mannered in the life, which would help you to grow very in a structured manner. This made me to take merchant navy as one of the best option and a career which made later to become a passionate person or a passionate aspirant to take this merchant navy. And then I choose marine engineering as this part because rather than mechanical part, marine engineering made me differentiated me with a core uh, like what to say is core field where you get to know the every details about the missionary parts which you are going to lead throughout the life.
Okay, a bit. Uh, uh, it was good. Good, you told a story, which is nice. How you got inspired and all. So next we'll go into the Prashant. Can you tell me why do you want to join merchant navy? Prashant, are you there?
Hello, hello, sir.
Okay. Tell me why do you want to join merchant navy, Ibrahim?
Good evening, sir.
Okay.
I wanted to join the merchant navy because in my family there are so many seafarers. So from the eighth class, I wanted to join the merchant navy by seeing them. I inspired by seeing them, and I focused on my intermediate, and I graduated my engineering. And in bit confused in intermediate that I want to join in deck side or engine side. There is no idea to where to join. So I taken some suggestion from the higher post members, and I chosen the field as a engine side. So I done my mechanical engineering in our own district. So that's why I chosen mechanical field. So and also in merchant navy we also can uh, go through the worldwide, and not as the SCA but other companies can we can go as the other like different countries, and we can visit different places. So and I can be I can be friendly with the Indian side missionaries. So I'm a I'm passionate with doing the missionary things. That's it, sir. Thank you.
You're a bit stuck here and there, but it can go more smoothly also. You can tell more smoothly. There is a bit of stuck here and there. So anything you can't, what I would recommend to everyone for introduction is you can look yourself in mirror and recite your introduction, because most of the time an introduction is like a proper question. They will ask you this. They want to check your communication, how good you answer, and why merchant navy also is very good question that interviewer keeps on asking. So it is very good if you prepare answers for this. So, okay, Viraj, what will you do if you are in a dispute with your higher rank officer?
So as in dispute means you
Any fight, any
about
quarrel?
about a work or something or personal something.
It can be anything. You can tell. You can pick one. Personal.
Okay,
Okay, let it be personal.
if okay, if it's personal, I will quiet myself down. I won't further exaggerate it or tell my officers or seniors, superiors. I will try to control myself and we'll see if if it goes on again and again. If it repeats, then I shall consult my seniors and ask for advice. Okay, so that's it, sir.
Okay. Nagesh, I would like to hear your answers. What do you think you will do in such a situation?
Sir, I cannot understand your question, sir.
So basically, you are in dispute with your higher rank officials, maybe a chief engineer or a second engineer. What will you do in such a situation?
What situation, sir? I cannot understand, sir. What is
Basically, a quarrel or a fight.
what, sir?
Okay, okay, it's no problem. Leave it. So I think we can directly move on to the technical sides. So Rahul, can you tell me the types of pumps you know?
So, types of pumps is classified into two types. That is centrifugal pump and positive displacement pump. And centrifugal pump we can classify into axial flow pump and positive displacement pump into screw pump, gear pumps, and etc. Diaphragm pumps, etc.
Okay, positive displacement, which one are you told?
Screw pumps, gear pumps, diaphragm pump,
You can tell it is again distributed into reciprocating and rotary
reciprocating.
and
Okay.
rotary. Okay. Viraj, can you tell the answer?
Yes, sir.
Types of pump.
So pumps are divided into mainly two types. First is centrifugal pump, and second is reciprocating. In centrifugal pump, there are axial type gear pumps. Sorry, there are axial flow pumps, and in reciprocating pumps, there are gear pumps and piston based pumps.
No, 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 that is not proper. So pump is divided on rotodynamic and positive displacement. In
Yeah.
rotodynamic, there is centrifugal and axial. In positive displacement, you have reciprocating and rotary. In rotary, you have screw, gear, vane, anything like that. And in reciprocating, you have diaphragm or piston pump. So, would you like to say again?
Okay. Some pumps are mainly divided into two parts, which are centrifugal and reciprocating. In centrifugal, there are two types, centrifugal force and the pumps based on centrifugal force, which are axial flow pump, and in reciprocating pumps, which are rotodynamic and uh,
No, no. So, pumps are classified into two, rotodynamic and positive displacement.
okay,
Rotodynamic and positive
rotodynamic and
displacement.
positive displacement.
In rotodynamic, you have centrifugal and axial.
Okay,
And in positive displacement, you have reciprocating and rotary. Okay. In
yes, sir.
positive displacement, you have reciprocating and rotary. In rotary, you
Okay, sir.
have screw, gear, and vane. Whereas in reciprocating, you have piston or diaphragm. Okay. Okay, Mugesh. Can you tell what are the types of pump?
Pumps are classified into two types. One is reciprocating pump. Another one is rotodynamic pump. In rotodynamic pump, the centrifugal pump, reciprocating pump, no, positive displacement pump. They are divided into two types. One is reciprocating, another in rotary. There is rotary, there is a screw pump, gear pump, hand pump, blow pump, and reciprocating pump, the piston pump, plunger pump.
Okay, and in rotodynamic,
What's up?
and rotodynamic, what are the types?
Rotod, I don't know, sir.
Okay, it is centrifugal and axial. Okay,
Okay, sir.
okay. Mm, Rahul, would you like to answer?
Sir, in pumps there are two types, that is rotodynamic pumps and positive displacement pump. In rotodynamic pumps, still it is classified into two types, centrifugal pump and axial pumps. In positive displacement, it's been classified into rotary pumps and reciprocating pumps. And in rotary, it is screw pumps, gear pumps, and vane pumps. And next, in reciprocating pumps, we have diaphragm pumps and piston pumps.
Abhishek, would you like to answer that?
So, the first classification of the pumps are initially on the two bases. First one will be the rotodynamic pump, and the second one is going to be the positive displacement pump. In case of positive displacement, there are two types: reciprocating pumps and there are reciprocating and rotary pumps. In rotary pumps, there are vane pumps, screw pumps, and gear pumps. In reciprocatory, there are diaphragm pump and single acting and double acting pumps. In case of in case of rotodynamic pumps, there are axial pumps and centrifugal pumps.
Okay, is there anybody who would like to tell me how centrifugal pump works?
So what
Okay, centrifugal pump working. Can you explain, Abhishek?
the working principle of centrifugal pump?
The entire working of centrifugal pump. How does
Okay,
it work?
so the centrifugal pump works on the principle of centrifugal force. So what happens is that the suction head is created between the sump and the centrifugal pump. The water enters the centrifugal pump through eye of the impeller, where as we know that the area of cross section between the impeller and the volute casing increases gradually. So as area increases, we know that the equation of continuity, area increases, velocity decreases. As the velocity decreases from Bernoulli equation, we know that kinetic energy decreases, so pressure energy will increase. So on the discharge side, we get the pressure energy. So that's how the fluid from the centrifugal pump leave through the discharge of the centrifugal pump.
Okay. That is discharge. Suction.
Suction.
How is suction pressure created?
Uh, uh, so, so in on the initial basis, the suction impeller rotates on the higher velocity. So as we know that the air is compressible in nature. So to avoid that, we first initially add few amount of water. So water is incompressible in nature, so it moves the water in higher velocity, and the vacuum is created in the eye and the sump. So that's the difference. The water enters the centrifugal pumps and the head is created.
Okay, this process of adding water, what is it called?
uh, what's priming actually.
Okay, okay,
It's
okay. Viraj, would you like to tell the answer? How does a centrifugal pump works?
So at the start, the impeller creates a suction head so that the fluid comes in contact, gets sucked at the eye, and the impeller starts its function as it rotates. It uh, it discharges the fluid through the discharge pipe of the centrifugal pump.
Okay, more clear answers can be given. Have you checked out the centrifugal pump video of Gyan?
No, sir, I haven't.
Okay, I would recommend to all of you his VCRS cycle video, which is important, the centrifugal pump video, the Anglo top 30 video, which covers most of the GME basics questions that is asked across throughout any GME interview that you are attending. It is best to see the Anglo top 30 questions, which I will be sending in the group after this. Don't worry. So if you go through that, you will get most of the GME basics questions so that you can answer properly. Mukesh, would you like
Yes,
to answer?
Basically, centrifugal pump work on the principle of centrifugal pump is the rotodynamic pump work on the principle of centrifugal force. The suction pressure is created in the eye of the impeller. Eye of the impeller. Which centrifugal force is created in the impeller eye, and water will move radial outward, and the water will move water will move on the casing through radial outward to the discharge side.
Okay. Okay. What principle does it work on, Mukesh? How is suction
Cent-
and discharge pressure created?
Suction and discharge pressure is created on the impeller eye due to the centrifugal force.
Okay. So basically, how I would answer it. So centrifugal pump is a rotodynamic pump. So the basic construction is that it has a suction pipe. It has an increasing area volute casing. Then it has a discharge pipe. It has an impeller also and an eye of the impeller at the center. So when this impeller starts rotating, it will displace whatever water is there because it is already primed, right? So whatever water is there at the eye of the impeller, it will displace it, which will create a void or a suction, because of which a suction pressure is created. Now after this is done, this impeller will throw the water radially outwards, and because there is an increase in area, the kinetic energy will be converted to the pressure energy according to the continuity equation, because of which discharge pressure is created. Okay, that is the working of centrifugal. Does anybody know how working of gear pump? Ibrahim. Ibrahim, are you there? Ibrahim. Okay. Varun, would you like to tell the working of gear pump? Varun. Okay. Mukesh, would you like to tell the working of gear pump?
Yes, sir. Gear pump is work on the principle of positive displacement, in which there are two gears are attached in the casing. First is driven gear and driven gear. And the lube oil is entered into the gear pump with moving with the teeth intermediate, and in which uh, the pump is required high pressure So area decreases, pressure increases.
Okay, again, I'll tell you the answer, but I want somebody to tell me back. So basically, gear pump contains two gear, the driver and the driven gear. So at the suction side, the gear will be coming out of the machine, which means there will be an increase in area. When there is an increase in area, there will be a decrease in pressure. So suction pressure is created. Now on the discharge side, because the gears are coming into the mesh, there will be a decrease in area, because of which there will be an increase in pressure. That's how suction discharge pressure is created. So Rahul, would you like to tell how gear pump working is?
So the pump basically works like we have two components, which is the driven shaft and the driving shaft. So the driving shaft sucks the as it rotates, it creates a vacuum pressure, which heats the water and it passes through the teeth of the components. That is the driving shaft and the driven shaft. As the area increases at the discharge site, the velocity also increases, and the fluid is being passed through.
Okay, okay. Abhishek, would you like to say how gear pump works?
So actually, the gear pump is a rotary pump which works on the principle of interlocking of volume. So the amount of water or the fluid enters the gear pump is the equal amount of volume of the fluid leaves the gear pump. So gear pump has two gears, driven gear and driving gear. So initially at the suction side, as the area increases, the pressure drops take place. So drop take place, due to which suction head is created and the fluid enters the gear pump and it follows a path. After on other side, discharge side, the area is converging. So area is decreasing and the pressure is increasing, due to which discharge head is created on the gear pump.
Okay, okay. Viraj, would you like to tell the working of gear pump? Abhishek, your
Yes, sir.
answer was good, okay?
Gear pump is a positive displacement pump. It has an gear. It has two gears. One is a driver and second is idler. One is driver and second is idler. Both gears are into a shell, or uh, at the suction end, there is a increase in area which creates the suction pressure, and at the discharge end, there is decrease in area which increases the pressure when the fluid goes when the fluid is passes through discharge. The gear pump also has a relief valve, because if the pressure is somehow too much or increases too much, the relief valve can open up, and it can uh, it can make the fluid go back to its source. That's it.
Okay, Viraj, since you mentioned the relief valve, does the centrifugal pump also have relief valve?
No, sir, centrifugal pump does not create enough pressure, and its involute casing is enough to handle the pressure that it can create. So it does
Okay,
not have relief.
okay, good. Varun, are you there? Okay, Varun is still not there. Um, oh, Varun, okay.
Yes, sir.
Tell
Tell me, sir.
gear pump. Okay,
A gear pump is a type of a positive displacement pump, and gear pump has a two gears and driven and a driver gear. And the suction pressure creates increasing the area and decreasing the pressure. And discharge pressure is creates and decrease the area and increase the pressure. So the function will be occurs in this process.
okay, still unclear about a little bit. Okay, we'll move on to the VCRS side. So Rahul, would you like to explain the VCRS cycle? Okay. Viraj, would you like to explain the VCRS cycle?
Yes, sir. So VCRS cycle consists of basically four main parts, which are a compressor and condenser, an expansion valve, and the evaporator. So basically, the uh, when the refrigerator is passed through the compressor, it compresses the refrigerant, um, which is then passed through the condenser. The condenser cools the refrigerant and sends it to the expansion valve. The expansion valve the expansion valve is connected to the end of the evaporator to the to a dry bulb, which tells the expansion valve how much refrigerant is to be passed uh, through it to the evaporator. So once the expansion valve passes the refrigerant to the evaporator then absorbs the heat. The refrigerant in the evaporator absorbs the heat and is again passed through the compressor. This refrigerant is passed through the compressor again. And this cycle repeats, sir. So it's a vapor compression refrigeration cycle.
Abhishek, would you like to answer the question? VCRS cycle.
So the initially the refrigerants enter the compressor through a low pressure cutout valve. So as it enters the compressor, the pressure which is around 10 bars and temperature around 50 bars increases the pressure increases up to 50 bars. So it leaves with a high pressure and a high temperature. So it is a superheated vapor. It is a superheated vapor and it enters the condenser. The process in the condenser is isobaric heat rejection. The cold water enters and the hot water leaves the condenser. And the pressure is higher side and the temperature is around 35 degrees. And it is a saturated liquid in nature. Then it goes through the dryer or it contains silica gel so to remove the moisture from the refrigerant. Then it enters the expansion valve where the isenthalpic expansion take place and the pressure and the temperature decreases after leaving the expansion valve. Then it enters the evaporator where isobaric heat absorption take place. And and uh, the uh, uh, entering the evaporator, the water vapor is around 80% and the vapor is around 20%, which after leaving the evaporator converts into 100% vapor. And at the end of the evaporator there is a sensible which contains a refrigerant to check the moisture level in the refrigerant so that the moisture refrigerant doesn't enter the compressor. As it enters, it will choke the whole system of the vapor compression.
Okay, Abhishek, what I would recommend you is not tell the pressure, okay? Let me guess, this pressure values you got from Dreamer package.
Yes, yes.
So
The
basically, okay, so
videos of.
basically he is trying to explain it to you, okay, so that you can imagine it well. So those are just example values,
Okay, okay.
okay, that is not universal values.
Mhm.
So that are just example values that Dreamer package trainees give to
Mhm.
make you understand much better. So rest of your answer was good, and it's better if you tell the phases in each states. Like let me try to explain the VCRS cycle. So what happens is low pressure and low temperature vapor refrigerant will enter the compressor, where it will be compressed to high pressure and high temperature uh, superheated vapor refrigerant. Now this superheated vapor refrigerant will enter the condenser, where it will lose its heat and be converted into high pressure, slightly low temperature um, liquid refrigerant. Now this liquid refrigerant will pass through the silica gel so that any moisture, if it is present, it will be absorbed. Then it will move on to the thermostatic expansion valve, which is like a orifice. So when it passes through this high pressure, high temperature liquid refrigerant will be converted into low temperature, low pressure liquid plus vapor refrigerant. So next it move on to the evaporator. So whatever this liquid refrigerant that is remaining, it will absorb the heat from the surrounding and convert itself into the vapor refrigerant. And this sensing bulb that is fitted after the evaporator will sense if any liquid refrigerant is left behind, because if this liquid refrigerant is passed through the compressor, since liquid is incompressible, there might be a chance that the compressor will burst. So that is one of the thing about sensing bulb, because sensing bulb is directly connected to the thermostatic expansion valve. So in case there is any liquid refrigerant, it will be controlled at the thermostatic expansion valve. So that is the explanation of VCRS cycle. So this is how you should explain the VCRS cycle, and I'll send you guys a video of Gyan so that you can know the VCRS cycle much better. He has explained very nicely. So we'll move on to the next question. Who was the marine engineer here? One guy was a marine engineer, right?
Sir, yes, sir.
Ah, okay,
Sir, I am also, sir.
okay. Can you tell me the use of boilers in ship?
Sir, okay, like it is not as considered to be the main engine side. Like we have auxiliary engine, which gives us the main power source for the auxiliary machineries, like electrical supply to all over the ship, and it produces auxiliary power to all the machineries, like pumps, motors, and domestic and commercial heating, like bunkering, fueling, etc. Sir.
Okay, so to heat the fuel, is it?
Yes, sir. To heat HFO diesel and
Yeah,
to maintain its viscosity throughout
yes,
the
yes.
voyage.
Okay. Who was the second marine engineer? Varun, was it you? Okay. So a universal question, mostly everybody should know. If you are a mechanical engineer or marine engineer, I want to know the parts of an diesel engine. Abhishek.
So, parts of the diesel engine, I'll go from the top. So,
Okay.
first there is a cylinder head, there is a piston, in piston there is a crown, piston crown, and piston skirt. Then there's a piston rod, which is connected with the crosshead bearing to the connecting rod. After that, there is a crankshaft, and there is a cam and camshaft setup. Then there is a A-frame. Then there is a entablature.
Crosshead bearing, piston rod, connecting rod. Did you say connecting rod?
Yes, yes.
Did you say piston rod?
Ye- hmm.
So both should be there in
No,
case
no,
of
no.
crosshead bearing, right?
Piston, no,
You mentioned crosshead bearing, right?
yes, yes.
Okay, you tell me a normal IC engine, normal bike diesel engine parts.
Diesel engine. Then there is a piston head,
Hmm.
a cylinder liner, uh, there is piston crown, piston skirt, then diesel, the piston rod, then crank, crankshaft,
Okay,
uh, cam and camshaft. Then there is a rocker arm setup,
okay.
and then there is a inlet port, scavenge port, and exhaust valve.
Tell me a four-stroke one.
Four stroke.
Hmm. So
Four
basically you can
stroke.
tell inlet valve, exhaust valve, and there is something unique to diesel engines, right? Which is that
There's a scavenge port in diesel
Fuel injector.
fuel injector.
Okay. Mukesh, can you tell me parts of a petrol engine, a basic petrol engine?
Petrol engine, scavenge port, carburetor,
Okay.
mm, piston rod, crankshaft, camshaft, flywheel, mm, exhaust valve, mm, piston rings,
Okay.
mm, connecting rod.
Okay.
That's
Okay. So how would I answer this question is first we have the uh, cylinder head, we have the piston, we have gudgeon pin, we have connecting rod, we have crankshaft, we have flywheel, we have camshaft, then we have rocker arm, inlet valve, exhaust valve. And whenever they ask petrol or diesel, the thing they want to know from you is it spark plug or fuel injector? Both of you have not mentioned that. When I ask diesel, I want to know fuel injector. When I ask petrol, I want to know about spark plug. Okay. Um, Viraj, would you like to tell petrol engine, parts of petrol engine?
Yes, sir. So petrol engine has a bed plate, A-frame, piston, piston rod, piston pin, uh, cylinder liner. It has stuffing box. So it was a petrol engine, right?
No, what you are telling is about a two-stroke diesel ship engine. Okay.
Okay, two-stroke diesel.
What I am asking is just a simple petrol engine. You gave me the parts, not go so advanced.
Okay, sir.
A simple petrol
Uh,
engine parts.
so a cylinder liner,
Okay.
piston, inlet valve, exhaust valve, um, and petrol engine. So spark plug,
Okay.
uh, and so connecting rod,
Okay.
crankshaft. It doesn't have camshaft, but it has something to control the valves. No, petrol engine doesn't have a camshaft. It has open ports for inlet.
No, petrol engine also has camshaft for it. Open ports is for two-stroke. Basically, if it is a two-stroke, then it has a open port. But for universal petrol engine, like I said, there is camshaft which will control the inlet and exhaust valve, and even the then spark plug also, which is not controlled by camshaft, but it has a spark plug also.
Yeah.
So okay, mm, we'll move on to the parts of ship. Can anybody tell me parts of ship? Viraj, would you like to tell?
Okay, so a ship's bow, hull, uh, bridge, accommodations, uh, anchor. So
Okay.
that's it.
Propeller.
All right, propeller.
Okay. Can you tell me what is the mm, you told bow, right? Which part of the ship it
Yes.
is?
So it's the front part of the ship.
Okay. Mm, and the back is called?
Uh, uh, no, sir, I don't know.
You told
Hull,
the name, but you don't know which is the back side of the
hull,
ship. No, stern, stern.
stern.
So it is like bow, stern, and then you have starboard, then yeah, starboard, then port side. Yeah, port side. And then you can mention hull, deck, which you already mentioned. Then you can tell about engine room. Then you can tell about superstructure, which is known as the there might be accommodation also there. Understood? Can
Yes,
anybody
sir.
tell the marine engineers what is the parts of ship? Rahul, would you like to say parts of ship?
Uh, Sir, parts of ship is like from the forepart we have bulbous bow.
Yeah,
Uh, then we have the cargo holding tanks. Then next it comes to the engine room. Next we'll get below that is the bottom platform. We'll get the pump rooms. And next in the superstructure that is the accommodation. Below that we'll get the like basically we have divided three parts engine room into. Bottom platform, middle platform, and top platform. Top platform will keep all the emergency equipments, that is a fire station, and main auxiliary for emergency pumps, emergency motors. Then middle platform will keep about the engine stop bases, and in the bottom platform we'll get about the pumps which are required for suction. Then we'll go about to the anchor, deck, hull, bridge, rudders, and propellers.
yeah, okay. You can tell stern also, right?
Yes, yes, aft side, stern side.
Okay, okay. Yeah, your answer was good. Um, Varun, would you like to tell the parts of ship? Varun, are you there? Okay. Rahul, one more question to you. Can you tell me the machineries that are present in the engine room?
Uh, 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 Machineries like engine room, we have main engine low boil pump, seawater pump, main seawater pump, main diesel oil pump, then the main engine pumps, main engine, then uh, like crankcase, oil mist detector system, then uh, mm, propulsion systems.
Okay, okay, Rahul. So you guys must be wondering why I'm asking these questions. But basically, these questions were asked to GME aspirants who went for interview. Even if you're a mechanical engineer or marine engineer, these questions were asked. Like, what are the parts of ship? Then they go on asking what is the machineries that are present on the machine on the engine room. So these questions were asked. It is not an unethical questions to ask you. So Abhishek, would you like to tell what are the parts of ship?
So first one is going to be row, which is the front part of the ship. Second one is going to be anchor, which is actually used to hold the ship or to deck the ship. Third one is going to be deck. Fourth one is going to be stern, which is the back side of the ship. Fifth one is going to be kneel, which is the backbone of the ship. Sixth one is hull, which is a part of the ship which is uh, extended over the water line so that the water doesn't enter the ship. The last one is going to be propeller to move the ship.
Okay, okay. Anybody like else? Viraj, would you like to tell?
Okay, so parts of the ship, starting from bow, which is the front of the ship, and deck, which is above ship, hull, which is extended over the water surface of the ship, stern, which is the backside of the ship, uh, bridge, uh, and the accommodations, and engine room. That's it, sir. And propeller.
Okay, okay. Okay, that is good. You answered most of them. Then we'll move on to the some of the basics questions they ask. Can anybody tell me Archimedes principle? Mukesh, why don't you tell me Archimedes principle?
When a body when a body is immersed In a fluid, it experiences upward buoyant force that is equal to the weight of the fluid displaced.
Okay. And Abhishek,
What was the question?
Archimedes principle.
So Archimedes' principle state that if the body is partially or completely submerged inside the fluid, it experiences a upward buoyant force which is going to be equal to the volume of water displaced by that body.
Okay. And Viraj, would you like to tell?
Yes, sir. So the Archimedes principle states that the upward buoyant force is of an immersed body in a fluid is equal to the weight of the fluid which is displaced by the body.
Okay. Rahul, the same question.
Archimedes' principle states that if a body is partially or fully immersed in the fluid, the weight of the body is equal to the upward buoyant force, which the, the upward buoyant force is equal to the weight of the water, that is the fluid, which is dispersed due to the immersion of the body, sir.
Okay. And Munay, would you like to answer Archimedes principle?
Yes, sir. Archimedes' principle is state that when a body is wholly or partially immersed in a fluid and a on it and with the weight of that is known as Archimedes principle, sir.
Okay. A bit of network problem there, but okay. Mm, okay. Can anybody tell me the three gas laws? That is the Boyle's law, Charles law, and Gay-Lussac's law. Mugesh.
Boyle's law, Boyle's law is temperature is constant, volume is inversely proportional to pressure. Charles law, um, pressure is constant, volume is directly proportional to temperature. Gay-Lussac law, volume is constant, pressure is directly proportional to temperature.
Okay. And it is also best that any laws that you study, keep one example ready so that when they ask you real life application, you can answer that also.
Okay,
Oh,
sir.
okay. Viraj, would you like to tell all three gas laws?
No, sir, actually, I forgot.
Okay, no problem.
Okay.
Abhishek?
So all the three losses. Actually, all the three losses are implemented on the ideal gas. So Boyle's law states that the temperature will remain constant, and the pressure and the volume of the gas are inversely proportional to each other. Charles' law states that the pressure will remain constant and the temperature is directly proportional to the volume. Gay-Lussac's law states that the volume will remain constant and the pressure is directly proportional to temperature of the body.
Okay. Um, Last question. I want to know all the thermodynamic law. Abhishek,
What's
thermodynamics law, first law, zeroth law.
so? The zeroth law states that when the two body having same temperature is first law talks about the conservation of energy. It state that the energy will remain conserved in all the states. Uh,
Okay.
and the zeroth law talks about if the if the if the body A and the body B are on the same temperature uh, and are with connected to a third body C, so all the three bodies will be on in the thermodynamic equilibrium.
Okay. And the second law.
Second law is second law talks about Clausius law and Planck's law. So,
Yeah. Explain
and,
that.
and Clausius law states that you cannot convert You cannot convert work into heat into work completely.
No, Clausius is like you cannot transfer temperature from lower temperature body, heat from lower temperature body to higher temperature
Without an
body
external.
without any additional work done. And
And
what about Kelvin Planck?
Kelvin Planck states that it is impossible to convert 100%
Mhm.
heat energy into work done.
Yeah, okay. And even the zeroth law, your sentence was not proper. It is like if body A and body B are in thermal equilibrium with the body C, then A and B are in thermal equilibrium with each other.
Yeah.
You told something same temperature. Like in
No,
theory,
no.
it is yes, but you can tell thermal equilibrium.
Okay, okay, I'll revise.
Okay, Rahul, all laws of thermodynamics.
In zeroth laws, we can define it as if body A and body B are at different temperatures, and if both comes in contact with the body C, then the three of the bodies will be at same temperature. That is thermal equilibrium. And in first law, uh, we can say that the state of energy can neither be created nor be destroyed, but can be transferred from body A to body B. And in second law, it can states that in a entropy of the closed system never decreases, and it's considered to be one of the most efficient process in heat engines.
Okay, basically Kelvin
And
Planck. It is better if you explain
uh,
Kelvin Planck and Clausius statement because entropy, yeah, it is okay, but it is better if you explain Kelvin Planck and Clausius.
okay, okay, sir.
Okay, so
Then
basically, yeah,
third law. Oh,
yeah,
yes,
third law.
finish, sir. Yes, sir.
Okay,
Clausius and Kelvin lengths.
okay. There is also a third law if you want to mention. It's like no system can reach absolute zero temperature. That is the third law. So basically, the zeroth law states that if a body A and body B are in thermal equilibrium with body C, then A and B will be thermal equilibrium with each other. That is, if A is at 40 degrees Celsius and C is at 40 degrees Celsius, then A and C is in thermal equilibrium with each other. And B and C is at 40 degrees each also, then B and C will be in thermal equilibrium. So A and B will also be in thermal equilibrium with each other. That is the zeroth law of thermodynamics. Now in the first law, energy can neither be created nor destroyed, but can be converted from one form to another, not one body to another, one form to another. It can be also converted to one body to another, but it is better to tell one form to another. Next is the Kelvin Planck, which tells us that the heat that is the heat is that is there, it cannot be converted into 100% efficient work. Some amount of losses will be there. That is Kelvin Planck. And Clausius states that heat cannot be taken from lower temperature to higher temperature. No, higher temperature, no, lower temperature to higher temperature without the aid of external work. So that is the law of thermodynamics. So basically, your mock interview is complete here. So I would like to tell communication is very key in the interview. So how you are able to convey your answers to the interviewer is very key. And all these basics you should know. IC engine parts, pumps are some of the basic questions they ask. Parts of ships. So it basically depends on the company. Some company focuses more on the HR part, like introduction. What will you do if there is a dispute? Why do you want to join merchant navy? They go into your father's mother's profession. Why are you not? Why are you not going to their profession? Why are you joining merchant navy? And are you ready for all the tough works out there? So basically, that type of question is the HR type. And there has been some instance where electrical questions also been asked, like what is the Ohm's law and things like that. So all the electrical laws, voltage laws, things like that also. And sometimes even the working of a motor is asked. Three-phase induction motor, uh, three-phase induction motor. things like that also has been asked. So I would tell you to prepare in a more basic manner. Make sure that you can answer everything sensibly. Don't sound stupid. Don't fumble in between your answers. So that is the advice that I would like to give you guys. So I think that concludes our mock interview. If anybody has doubt, you can ask now. Any doubt regarding anything?
So
Okay.
regarding the dispute question, what would be the correct answer?
So there is no correct answer for this. What I would like to tell is, even if there is a dispute with the seniors, I think that the seniors might be in the right side, and that we'll not further uh, increase the dispute and let it finish then there itself. Okay.
Okay, sir.
Any other doubts with any question, technical, non-technical?
So in zeroth law, you said that
So from non-technical
thermal
side,
Yeah. Viraj, you go on.
so in zeroth law, you said uh, thermal equilibrium should be in between two bodies or two systems.
It can be two bodies or two systems also. You can tell systems, it's much better. Okay.
Okay, sir.
Okay. And Rahul?
so from non-technical side, like how like from for introduction, is there a limit like we should be within this much second, and how to keep our communication better, sir? Because if you are nervous, our communication will be dull.
Okay.
It will be lower.
Okay. So basically, how I practiced first is to give mock interview sessions like this. Second is practice in front of the mirror. Introduction is a must question, so you know it's going to come. So
Yes,
it
sir.
is
It
better
is
if
the
you,
one like a first impression.
yeah, yeah. So introduction matters very much. They want to know everything about you in a very direct manner. So name, your workplace, what does your parents do, what percentage, what is your achievement, what is your interest, and there might be a chance that from that interest only they might ask you questions. So all the questions that you answer, keep it in mind that you might get cross questions from that. Okay, like if
Okay.
you tell that I'm interested in such so and so thing, they'll ask you questions on basis of that. Even while introducing, maybe you tell, oh, there is a hilly area, they might ask some questions about the hill area. Uh, what is the air pressure there, where air pressure is more in hill area or in the lower ground sea level, things like that. So they search for things like that so that you say something to them and they can ask cross questions, which has been in most cases. So I'd like to tell, think about the answers that you are going to give, and because if you try to boast too much or show off too much in your interviews, they will catch it and ask on basis of that. So that is the thing I would like
Okay.
to tell about giving answers. Any other doubts? Okay, there is no doubt. I
And
thank you
one
for,
thing I want to ask is
yeah.
regarding they will ask to draw the diagrams. Should we keep a practice of that?
Yeah. Basically, which diagrams I practiced was IC engine diagrams,
Mm,
uh, IC engine diagrams, then centrifugal pump, gear pump,
mm,
VCRL cycle,
mm,
then yeah, the wall diagrams, basically wall indication
mm,
diagrams of diesel engine, four stroke, then
mm,
petrol engine four stroke, then two stroke diesel engine also. These wall diagrams I studied for my interview.
mm,
So this can be asked. Okay, so I basically it's up to the interviewer. They can ask anything in your mechanical engineering or marine
mm.
engineering from you. So it is up to them. They can ask more HR questions or go very technical with you.
Okay. Thank you.
Any other doubts? Please open up, guys. Any doubts you can ask. That how much ever silly it might be, you can ask. Okay.
So can you say that again? Means how to how what
Yeah.
इंट्रोडक्शन में मतलब कैसे करते हैं सीक्वेंस कैसे है व्हाट इज द सीक्वेंस ऑफ इंट्रोडक्शन कैन
तुझे
यू
क्या
रिपीट दैट अगेन
important लगता है वही first tell. See, first of all, you can tell your name, If you have occupation or tell that you have passed out mechanical engineering. You can tell the CGP or percentage. You can tell the percentage of 12th where you did your 12th. 12th is enough, I guess. I don't go below that. I don't think it's much important. You can tell about where you are from. You can tell your parents' profession, mom, and even your siblings. If anybody has profession, you can tell that. You can tell your regarding your projects, what project you have done. Then interest and achievements. This is the way you can tell the introduction. And
Oh,
introduction, see, mostly it's about your communication skill. Okay, they want to see if you are confident. So I would recommend you to not fumble too much. Be confident in a continuous flow. You tell. Don't tell. When I say continuous, people usually tell it like a mantra. So don't be like that. Also, very calm, confident. You have to tell your introduction. Okay,
okay, sir. Thank you.
and the confident and calm part is very much important also. And also, while answering any question, be sensible. Don't tell stupid things. Okay, even if you don't know, you should say you don't know, because if you tell stupid things, that makes even more bad impression to them. Okay. Okay, any other doubt? Yeah, telling. Okay, why do you want to join virtual navy? You can tell many things. First of all, if anybody has what do you say, stories like I was inspired by my uncle, or there has been many cases where your relatives or close cousins already joined merchant navy, because of which you wanted to join merchant navy. That is a very good answer. Second, you can tell about financial stability, because everybody knows merchant navy is a place where you get paid very high. So instead of directly telling I want money, you can tell I will get financial stability. Another good point that was mentioned here was that promotion are based on the written exam that you do. It is not favoritism. It's not based on favoritism. So it's much better. Next is the passion toward traveling. You'll get to travel a lot. And the finally, you can tell that it is a very core mechanical field. Since I'm a mechanical engineering, I think my all 4 years of engineering, whatever I studied, it will be much more applicable towards here rather than working in any sales or IT companies. So that is the answer I would like to give. Any other? Any other doubts? Okay. So I think we'll end
So
the
what about our internship?
internships. Yeah, we can tell about internships also. Basically, your introduction is like telling everything about yourself to your interviewer in a brief manner. Okay, not extended too much also. Don't tell very little things also. There should be a perfect balance of them knowing everything about you. Okay, internships also can be told if it's related to shipping industry, it's even better. Obviously, since you are a marine engineer, I think it might be related. But other people, if
Yes, sir,
it's
it's related.
yeah, if it's yeah, like if it is related, you can tell. But when you tell about internships, they will also ask you like what have you done in the internship, what values have you gained from that. So you can expect questions from that also. Okay.
Okay, okay, sir.
Anything else? Anything else? Any other question? Okay. So I guess that will be the end of the session right now. Thank you all of you for attending the session. Thank you very much.